What is eutrophication? It is the process by which a body of water gains a high concentration of nutrients, especially phosphates and nitrates, which promotes algae growth, depleting the water of oxygen and causing organisms to die. The most common phytoplankton in the Arabian Sea and the producer for the food chain were diatoms up until recently, when they were replaced by Noctiluca scintillans, a bright green phytoplankton. Why is this happening? Humans are dumping trash and fertilizers into the ocean, which causes an increase in nutrients and a decrease in oxygen concentration.
Industrial and domestic outfall come from countries surrounding the Arabian Sea, which discharge severely oxygen-depleted and nutrient-rich domestic wastewater. Noctiluca scintillans thrive in these hypoxic conditions, and the added nutrients allow for rapid and consistent growth. There's an excess of nutrients, so the population grows exponentially with very little competition, a perfect home for these plankton. Now, this accounts for the very dense populations of scintillans in the Arabian Sea. There are several problems with these blooms. One is that it blocks much of the available sunlight from ever penetrating the surface of the ocean, depriving organisms under the surface a constant stream of energy. This reduces growth and kills off entire plant habitats and the organisms who depend on these habitats. Furthermore, whenever these organisms die, microbial organisms decompose and deplete the available dissolved oxygen in the water to levels that cannot support most marine life, and this is called a dead zone. For an ocean that feeds up to 100 million people, a dead zone and recurring blooms are huge problems for this major food source and lucrative.
The decrease in snow cover has led to greater differences in both temperature and pressure systems between the Indian subcontinent and the Arabian Sea. These pressure differences generate monsoon winds, which are seasonal changes in the direction of the strongest winds of a region that mix the ocean water in the western Arabian Sea. This mixing leads to better growing conditions for tiny free-floating ocean plants called phytoplankton. The difference in pressure causes the winds upwelling of cooler nutrient-rich water, creating ideal conditions for phytoplankton to bloom every year during summer. And that is the problem. Since 1997, a reduction in snow has led to wider temperature differences between the land and ocean during summer. As a consequence, sea surface winds over the Arabian Sea have strengthened, leading to more intense upwelling and more widespread blooms of phytoplankton. While large blooms of phytoplankton can enhance fisheries, exceptionally large blooms could be detrimental to the ecosystem. Increases in phytoplankton amounts can lead to oxygen depletion in the water column and eventually to a decline in fish populations.
As previously mentioned, dead zones in the Arabian Sea contain hypoxic waters, which have low levels of oxygen that lead to a decrease in carbon fixation by diatoms and an increase in N-scintillin blooms. If diatoms cannot fix carbon, then they die. N-scintillins also eat diatoms, which further decreases their population. N-scintillins fix more carbon and are eaten by salps and jellyfish, whose waste products contribute to carbon being delivered to deeper waters as the pellets fall, which in turn increases the water's susceptibility to low O2 levels.
Controlling the rate of population growth urbanization can play an essential role in reducing the amount of N-scintillins produced. When these dense algal blooms eventually die, microbial decomposition severely depletes dissolved oxygen, creating a hypoxic dead zone, lacking sufficient oxygen to support most organisms. However, there are some remedies that can help this, and these include 1. Diversion of excess nutrients, 2. Altering nutrient ratios, and 3. Application of potent algicides and herbicides. In general, these strategies have been proven to be ineffective, costly, and or impractical, especially for large complex ecosystems. In addition, a research carried out in Japan by 3 scientists helped show positive effects of ultrasonic irradiation on green algae, in which they considered the factors affecting their sedimentation and death.